Hi everyone, and welcome. Thank you for joining Excel Virtually Global. Let me set the scene. Imagine walking into your own workshop, and all the usual tools are there, but among them you have a few custom-made gadgets, the ones nobody else has. They're the tools that make the trickiest jobs easy, and you often wonder how you ever manage without them. That's what custom functions in Power Query represent. Solve a problem once, wrap it into a function, and from that moment on, it's ready whenever you need it. By the end of this session, you'll know how to turn M code into a custom function, but you won't leave with theory alone. You'll also have a few custom gadgets that you can put to work immediately. I'm Korte, and I've been hanging around the Power Query workshop for nearly a decade, answering questions, sharing solutions, and over time creating other content as well. But my passion is still the same, making data prep easier and who knows, even just a little bit more fun. I'm a community super user, Microsoft MVP, and co-author of the definitive guide to Power Query M. There's a QR code on this slide that leads to my GitHub page where I share code samples. There you'll also find a link to LinkedIn if you want to connect. How many of you have ever thought, I know I've solved this before, but where? Where is that solution? Or maybe you've repeated the same data cleaning steps once, twice, okay, perhaps maybe 6 times already this week. Custom functions break that cycle. So what is a custom function? Well, basically it's a routine that you can define. It can take none, one, or multiple inputs, but it will always return just one single output. That output can be a number, a text, or something a little more sophisticated like a list or a table, for example. But it's always just one thing. Power Query comes equipped with well over 800 functions, and often we duct tape some of them together into an ad hoc solution. Today is about turning those assemblies into reusable gadgets, moving from rebuilding to reusing. That will speed up query development. You'll never have to reinvent the wheel again. And it provides consistency, the same logic every time, to ensure a more predictable outcome. Alright, let's talk theory. And don't worry, it's easier than it looks. So every custom function follows the exact same pattern. Think of it as a blueprint. It starts with a set of parentheses, which is followed by the goes to sign, the combination equals greater than. And after that follows the function body. That's the part that contains your routine. And that's it, just 3 things. Parentheses, goes to sign, and the function body. Every custom function in the M language follows that exact pattern. Want it to do something useful? That's where parameters come in. Parameters act as a placeholder for arguments you can pass to your function. And here's how that works. So inside the set of parentheses, you can declare your parameters, separated by a comma. In this example, there's one parameter, and its name is D. If you need another parameter, you would simply insert a comma and provide another name. Then comes the goes to sign, right, which is followed by the function body. On line 2, you'll see D, our parameter, has been passed to a function called date.dayofweek. As you can probably guess, the purpose of this function is straightforward. It returns a weekend label for dates that are Saturday or Sunday, and weekday for all other dates. But what if you pass a text instead of a date value? Then this function will fail. It's like pouring orange juice into the gas tank. Not recommended. And that's where data types come in. Data types are like instructions to put the right fuel in the tank. By setting expectations, you make your function more reliable. And this is what that looks like. The argument provided for D is now expected to be compatible to a date. And the output, or the return type value, is also declared as a text. Now, our gadget isn't just functional, it's dependable as well. Quick recap. Every custom function has 3 parts: parentheses, goes to sign, and a function body. Parameters live inside those parentheses. They're required unless declared optional, and data types keep functions dependable and less error-prone. So let's head to the Power Query editor and look at a few common data prep challenges together. Now, there's never just one way to solve a problem, but today our goal is this. We want to create one approach and turn that into a custom function. Here's our first task: removing blank columns. Picture this. You've imported data from a CSV file and immediately spot there's an issue. It's got blank rows and blank columns as well. Of course, that's not what you want. Removing those blank rows turns out to be very easy. Power Query has a button for that. But somehow, there's no feature to remove blank columns. Let's sort that and build one together. I've fabricated this sample data. It's a mix of numbers, texts, nulls, and empty text strings. Enough to start exploring. To kick things off, I'll invoke the option that removes blank rows. Because once we understand that pattern, maybe we can borrow that idea and adapt it. So here it goes. I'll go to remove rows, remove blank rows. In the formula bar, there's one line of code with nested functions. Nested functions run from the inside out, so let's untangle this. To make that easier, I've formatted the code in another query. So let's remove this step and take a look at that. I'll expand the formula bar. At its core, we find the function record field values. That takes the current row and turns it into a list of row values. Wrapped around it, we see list remove matching items. That takes that list and removes any empty text strings and nulls from it. Now, if nothing remains in that list, the row is empty and it gets removed. Else the row stays. I think this is a pretty neat approach, but we'll need to adapt it to make it run vertically across columns. This is where you can start rubber ducking the problem. Talking through it out loud can help. So instead of table.select rows, the function here will need to select columns. That much is clear. To take a look at the syntax for table.select columns, I can actually use the UI. I'll select a few columns, right-click the last one, and select Remove Other Columns. So here's table.select columns, and it just has 2 arguments there. First, we see a table on which it was invoked. And then we see a list with column names. That list has hard-coded names. Now for a one-off, that could be fine. But for a custom function, we need Power Query to decide which of the columns to keep on the fly. I'll remove this step. Let's attempt building a solution inside the advanced editor. I know working in the advanced editor can be daunting at first, but I'll talk you through it. First, it's important to understand that what we are seeing here is called a let expression. It starts with a let clause on line 1, and it has an accompanying in clause on line 11. Between them, you'll find a comma-delimited list of variables or step names with expressions assigned to them. The result of a let expression is determined by whatever follows its in clause. In this case, that's the value returned by the remove blank rows step. Why not take that step? So we can use it as a blueprint. Here we go. I'll select it, press Ctrl C, place my cursor at the end, enter a comma, press enter, paste the code back. I need to update that step name because that needs to be unique. So instead of remove blank rows, we'll turn that into columns. And now I can return this after the in clause, making sure that this is the value that's going to be returned when we evaluate this let expression. Instead of selecting rows, we need to select columns. Let's update this function. There we go. Now that takes a table, and it already has one, that's the sample. Now I can press enter to go to a new line. Let's do one thing at a time and start by getting all of the column names first. So there's a function for that called table.columnNames. We need to pass that the table, and we're going to point to the exact same table. That's our sample. That will create a list with all of the column names from this table. But we don't need all of the columns. We need to select names based on the logic that's below it. So to select values in a list, we can use the function list.select. That will take our list and we'll apply this code. Now, of course, this, at its core, we're still moving on a row-by-row basis, but we need to provide a table column. Here we go, table column. And provide that a table and a column name. So we can point to our sample table again and provide the underscore to pass each of the column names that was generated by table.columnNames. Let's see if this worked. I'll press done. And just like that, we've reused the core ID of selecting rows and turned that into a working remove blank column step. Now that we have this routine, we can turn it into a custom function, applying the theory we covered at the start. I'll open up the advanced editor and I'll zoom in. Let's grab the code. Press Ctrl C to copy that. Done. I'll right-click my demo folder, select New Query, Blank Query, and I'll open the advanced editor again. Zoom in. And here I can just paste that logic. Let's indent that a bit and press enter. Here we go. So functions are initialized by a set of parentheses. So we can pass that. And to make it work on any table, we need to create a parameter to pass a value to this function. Let's call that TBL as table. Once this routine has been applied, we expect an output table as well. So the return type will be as table. Then we can pass the goes to sign, and below it we have the function body. Now it's time to update all of the instances where the table was referenced. The table that we used was sample, right? And we need to replace that by our parameter called TBL. I'll just copy that. And everywhere I see sample, I'm going to paste that in. Control V. Control V. And once more, Control V. Done. In the queries pane on the left-hand side, we can now see that this query is a function query. It has fx in front of the query name. But let's give it a proper name. Once you've turned your query into a function, it's a good practice to give it a test run. So here we go. I'll select my sample RBC query, that's this one, and press invoke. That looks good. No more blank columns. I don't need to keep this query, so I'll remove it again. Right click, delete. So now that we can remove blank rows and have a tool that removes blank columns, let's take it a step further. Why not combine these two solutions into a single custom function that can handle both blank rows and blank columns all in one go? The process will be similar, but because that involves multiple steps, the function body will have to contain a let expression. Let's go to our development query and open the advanced editor. I'll zoom in. And I can just grab all of the code here. All the way up to the sample. Press Ctrl C to copy that. Done. Create a new query. So right click my folder, new query, blank query, and open the advanced editor again. I'm going to keep the top let expression because I didn't copy that, and I'm going to paste back the code here. Go all the way up. Let me zoom in for you. Hit enter. There we go. I'll expand this a bit so we can see all of the code. So to turn it into a custom function, we need to initialize it with a set of those parentheses. Between them, we can declare our parameters. Again, we will need a table. I'll call that TBL again, as table. And the return type will be a table as well, as table. That's followed by the goes to sign, and below it we have our function body, which now contains a let expression. Now where it says sample, we'll replace it with our parameter, TBL. I'll highlight that, TBL. So normally the output of remove blank rows would have been passed on to the next step automatically. But because we copied the entire step and used it as a blueprint, we're now also referencing sample in remove blank columns. But once this transformation is complete, removing the blank rows, so I'm going to copy its name, we want to pass the output of that and process it further. So I've copied that, Control C, and I'm going to pass it in to our second step. Control V, Control V, and the final one, Control V. Let's double check if all of the samples, the sample references are gone. That looks good. All right. Now here's actually a chance to improve this function. Currently we're assuming that blanks mean either null or an empty text string. But maybe we want to discard other values as well. Let's make this function more flexible so it can handle that. First we need to provide a new parameter. I'll enter a comma there, and this will be an optional one. Optional blank values as a list. That means that our user can now choose to pass a list with values. Because blank values is optional, the user might not provide a value at all, and in that case, it will be a null. Should its value be null, we can apply the default set. That will require a conditional statement, so let's create another variable in this let expression. I'll call that blanks. And create a conditional statement using the keywords if, then, else, all in lowercase. So if blank values equals null, then we want to provide the default set. Control C, paste that there. Else, we'll use whatever the user has provided, so blank values. Don't forget to place a comma at the end. Perfect. So this way, if nothing is passed, we fall back to the default set, a null and an empty text string. Otherwise, we'll use whatever the user has provided. Now we can pass this variable blanks into both steps. Once for removing blank rows and once for removing blank columns. Press done. Let's give this query a name as well. Invoke it on our sample query. Sample RBC, invoke. And that looks good. All of the blank rows and the blank columns are gone. Time to test this with a custom list. So I need those curly brackets for that. And let's pass a null and a 0. Because I have a column with zeros here as well. I'll hit that check mark. Awesome. So the column with zeros is now gone, but the column with empty text strings now returns. That's column 2. That's exactly what we wanted. Let's add that empty text string back, okay? And update that again. Perfect. So what did we just do? We built not one, but we built 2 custom tools. A function that removes blank columns and an upgraded version that removes both blank rows and blank columns in one sweep, with the option to define what blanks mean. Both of them can go straight into your toolkit, ready to be pulled out whenever you need. I'll disable this from load and move it to my folder. So there we go, move that up. Let's dive into our second scenario. Tell me, have you ever seen text that looked like it lost a fight with Blender? Words scattered, gaps like Swiss cheese. It is a mess. And you'd think there'd be a quick and easy way to fix it. Wrong. The built-in text.trim function eliminates leading and trailing white space only. Looking at this sample, our problem is much, much bigger than that. I know people have shared workarounds through the years, but none, at least that I'm aware of, normalizes spacing around punctuation marks as well. That is our next challenge. We're going to develop a custom function for one of the most common text cleaning headaches, dealing with excess spaces. Time to roll up our sleeves. We are going to build this from scratch, but step by step, reviewing all of the intermediate values, before converting it into a custom function. To make that review process easier, we're going to develop that approach within a custom column. So I'll hit that mini table icon, add custom column. I already know this will take multiple steps, so we need a let expression or a record expression. The record is like a let expression, but it shows all intermediate values. Other than that, they're pretty much the same. Insert a name, assign it an expression, followed by a comma if you want to repeat that process. So here it goes. I'll give this column a name, let's call that trim. And here in the custom column formula area, I will enter a set of square brackets. These square brackets initialize a record expression. I probably never told you this, but I love splitter functions. And there's actually one that's specialized in dealing with whitespace. It's called splitter.splitText by whitespace. I'll create a field for that. I'll call that trim and assign that the splitter. What makes splitter functions special is that they have two stages. In stage 1, you configure your splitter for a specific task. It will then return a function. And we can see that if we press OK. I'm just going to leave it as this, press OK, click off to the side to my record, and there we see a function. Let's use the gear wheel to go back. In stage 2, you can invoke the configured splitter function on a value by simply adding another set of parentheses. Let's do that. And now between those parentheses, we can provide a value. Now in this case, we want to apply this splitter to all of the values in the string column. So in the available column section here, I can just double click it. Trim will now no longer return a function, but a list with values. Let's take a look. Click off to the side, and there is a list. We can actually drill down into one and take a peek inside. So I'll click on the record this time, and I can click off to the side again. Down below we see a preview, and that includes a blank. Now that needs to be removed. Let's go back. I'll X this step out, press the gear wheel again. There we go. Enter a comma at the end. Press enter, and now we can create a new field in this record. I'll call that list. Now when we examined the code to remove blank rows and adapted it to remove blank columns, we actually saw list.remove matching items. And it can be used for a task like this. So here we go. List remove matching items. We'll provide it our trimmed list, so trim, comma, and a second argument we can provide it a list with items that we want to discard. So create a list in a set of those curly brackets, and this time an empty text string. Another closing curly bracket and a closing parentheses to the function. Perfect. So this should get rid of those blanks. Let's take a look. I'll press OK, drill down, and take another look. Here we have a blank, and now that blank is gone. Awesome. I can remove that step again, press the gear wheel. I got rid of the blanks, meaning that if we put all of those pieces back together again, we're not creating new leading or trailing spaces. Now to combine all of those list items, separated by a single space, we can use the function text.combine. Here we go. I'll go to the end there, add a comma, press enter to go to a new line. This will return a string, and we'll use text combine. Pass it our list of values, and as a separator, a single space. That looks awesome. The first part of our job is done. All of the excess white space, and that includes tabs and new line characters as well, have been removed. But there are still some spaces around punctuation marks. Let's take a look at this one, for example. Time to fix that. First, I'm going to grab a set of default punctuation marks. Let's go back. Comma, and I've just copied that, so I'm going to paste that in. I've passed these marks as a string, which is actually a design choice. Later on, when we turn this into a custom function, I want to be able to provide users the option to add marks to this as well. We'll see that in a moment. For the next stage, however, we don't need a string, but I need a list with individual characters. Let's transform this base marks value. Here we go. Enter a comma, press enter, and let's call that marks. And we can use a function called text-to-list to split that string up into a list with individual characters. Let's take a look. Let's drill down. There we go. Now we can call upon another splitter to help us out. This time one that splits on character transition. Both conditions will have to be met. And we can split on any character that's followed by a mark. And here's what that will look like. I'll add a comma. Press enter. Let's call this clean. Splitter split text by character transition. That's the thing that we're looking for. Open that up. So before, that will be any character. So each true, comma. After, that will be any of our marks. Remember that this will return a configured splitter function that in turn can be invoked. We will invoke it on the str string, so in another set of parentheses, str. Let's examine that value as well. Now, where a split occurred, there may be a space present. We need to get rid of that, so we can trim that value. As our values are within a list, we can transform all of the values within it. Pass it our clean list, comma, and invoke the text trim function. That's looking pretty good. And the final step is to combine these items back together again, but this time separating them with an empty text string, so we won't be placing any spaces back. Let's take a look at all of them. Now that we have this pattern, we can use it to create a custom function. All I have to do is copy that record. I'll expand the formula bar and I'll copy it from here. So the opening square bracket until the closing one. Press Ctrl C. Let's minimize that again. There we go. Create a new blank query. So I'll right click my demo2, new query, blank query, and I'll open the advanced editor. Zoom in and paste in that record. Go all the way to the top, hit enter. Initialize the function by adding a set of parentheses. Now I can create a parameter. Let's call that string as text. Comma, and now we can add another parameter to give the ability to add additional marks. That will be an optional one, of course. So optional as text. And we're also handing back a text value, the return type as text, followed by the goes to sign. Time to make a few adjustments. We need to pass the parameters. But what happens when you forget? Let's test that so we can see what that looks like. I'll hold off on passing the text input called string. But I will update marks to include anything that was provided by the user. So here we go. To concatenate two strings, we can use the ampersand. And now we can call add marks. We need to remember that because this is optional, the value is nullable. Now combining a null with a string will yield a null as a result. We need to avoid that. And we can simply do so by applying coalesce. Coalesce is a double question mark. After which we can provide an empty text string. Now of course we need to make sure that this part is evaluated first. So we can enclose it in a set of parentheses, like so. In other words, if add marks is null, then use the empty text string. Else use whatever was provided. Now there's one final thing to do, and that is to grab the last field and return that as output to our function. So I'm going to copy that name, Ctrl C, and here in a set of square brackets, I can refer to that. Let's press done and give this function a name. We'll do a test run, knowing full well that we didn't pass the input parameter to our function yet. So here we go. I'll step back to my demo query. I'll use that mini table icon again. Select invoke custom function. We can give that a name. I'm just going to leave it as custom and select a function query, fxstring. Provided a string value, that will be in a column. So I'll select a column here and the string from the available options. Hit OK. And here we see an error. Let's take a look. So it's telling us there's an unknown identifier. Did you use a field shorthand outside of an each expression? It's important to recognize this. When you start creating functions on your own and you encounter a message that reads something like this, you most likely have referenced a field somewhere within the function body that still needs to be replaced by a parameter. Looking for things with square brackets in your code will help you fix that. So let's fix our function. I'll open the advanced editor. And now I'm going to look for things with square brackets. Now, of course, this doesn't count. This is field access. It will return the last value of this record expression. But here I see string in square brackets. That's the only thing in square brackets, right? So we can replace this with string. There we go. Hit done. And take another look. Now there's one error remaining, so let's also try to debug that. So I'll click off to the side on the white space. And it's telling us we cannot convert the value null to a type text. Now, as you can see in the column string, there's actually a null there, so that was our input value. There are a couple of ways to fix that, but in this case, I've got something special in mind. Let's go back to our function query, open that up. We've specified the parameter for string as text. That means that the argument provided has to be of a text type. Instead of that text type, we can make it a nullable text by adding the keyword nullable. That means the null value is now included in the text type. Let's press down and take another look. That resolved the issue. So what did we discover? A text trim only removes leading or trailing whitespace. We just build a function that cleans up all whitespace and closes gaps before punctuation marks. A record expression can be used instead of a let expression and allows you to see all of the intermediate values. And finally, all splitter functions return a function. They're kind of weird, but also useful. During this session, we built different tools together. In the first scenario, we tackled blank columns, a problem for which there's no ready-made feature available in the Power Query editor. We learned how to adapt an existing idea and turn that into something new. Custom functions don't have to be big or complicated. Sometimes they're small solutions, built with nothing more than code that was generated by the user interface. And sometimes they're carefully crafted, like our custom trim function. But the point is, no matter how your routine was created, turning it into a custom function is something that you can learn pretty quickly. I'll even be bold in stating that it's not that hard. However, every time you build a gadget, you're adding it to your own personal toolkit. Tools that make you faster. Tools that make your solutions more reliable. But above all, tools that let you prepare your data like a pro. That brings us to the end of my presentation. Thank you so much for joining me, and thank you for being a part of Excel Virtually Global. We'd love to get your feedback. Just scan that big green QR code on this slide, and you can do so. Enjoy the event. All the best.